Okay, let's recap what we were going over. Well, let's redo this question, okay? I'll redo it over here. Okay, so let's recap this. Now, I solved something using Pythagorean, but I should have realized they want us to use special triangles to solve everything. This is our theta. Was there any other information there? And this was 45 degrees, okay? Let's talk about the first triangle here. If this is 45 degrees, this side here, that means this angle here has to be 45. And that makes sense to you because they got to add up to 180? Yeah, okay. So if that's 45 and that's 45, anytime you have corners of a triangle that are the same, so the degrees are the same, that means that their corresponding sides, so this side and this side, have to be the same. So in other words, we're talking about 14, and we know this is going to be 14. One way we can show that is our 45-degree special triangle. We can think of that one also. I'll turn it so it looks like that one. So in other words, if we had 45 degrees, we know our special triangle. It's a good idea. You have to have these memorized, these two triangles. It's a good idea to always draw them out. We know that this is 1, 1, and the root of 2. The only difference is the triangle they've used. We'll do it in red here. This distance was 14. So if that distance is 14, all we're going to do is kind of set it up as a ratio. Well, we know that this distance is the same, so I also know that this side is 14. And then this number here, to get it, all they did was add the two sides together and put a square root over it. We know 14 plus 14 is 28, so this side is the root of 28. So that's what this would be. Root. We know that that's going to be the root of 28. Does that make sense, how I found that? Now, I'm assuming because you're using special triangles, she didn't want you to use Pythagorean's theorem to solve this stuff. Because technically then they'd want an exact number. You know, you'd get something like 5.3 something, something, something. The other triangle they had, we had this distance is 14, is they told us that the ratio of, I can't remember which Greek symbol this is. Beta? Maybe it's beta. They said sine beta. It's just a symbol.
Beta the other one.
Theta is this.
That's theta?
That's theta with a T. Beta, large beta is like this. I think that might be lowercase beta. We really don't have to know all this stuff. That's Greek letters. Okay. Let's make this simple. Sine x. Okay? I'm going to call it x. I'm going to call this x. Sine x is equal to 1 over 2. The other special triangle we know. The other special triangle we know is that 30 degrees, 60 degrees, and 90 degrees. Okay. Now, the best way to think of this is between 60 and 90 is 1. The hypotenuse is 2. And then when we add those two together, we get the root of whatever number that is. Okay? That's a fast way of setting that triangle.
So how do you know which triangle is which?
What do you mean?
Like, how did you know that was the second triangle?
This triangle? I don't know it's that yet.
Oh.
I'm about to check to see if it is. They've told us that sine x equals 1 over 2 as a ratio. We know that the distance, and remember that sine of whatever, that means, opposite over hypotenuse. Do you know that rule? Yeah, like SOHCAHTOA, do you remember that? Yeah. So, that means they're talking about this angle here, x, sine x. So they're talking about the opposite side is 1 to the hypotenuse. We know this is hypotenuse is 2. So we know that ratio is just set up like that. Okay? Now we got to possibly find out what this angle is and such. If they're telling us the ratio of the triangle is the opposite side is 1 and the hypotenuse is twice as long as that opposite side, it turns out that this triangle, if I called this sign, that wouldn't work. Because opposite of this is the root 3 and 2. So really that would be set up to look like sine x. Our opposite is root 3 over 2. Well, then I know that this can't be 60 degrees. Because if this was 60 degrees down here, we're talking about that, that's what our would look like. It's say root 3 over 2. So we know that it can't be 60 degrees. But if we were to do the other angle, so if we were to be here at 30, well, opposite is 1, hypotenuse is 2.
Okay.
So I know that this angle x is going to be 30 degrees. So I know this is 30 degrees. And I know that the ratio of this triangle is the opposite side. Whatever the opposite side is, the hypotenuse is twice as long. So because the opposite side they told us is 14, we know the hypotenuse has to be 28. And now we discovered that in the other example that this was 24 point something by Pythagorean.
Yeah.
What we could have done, I believe we could add those two together. No. We should be able to add those two together and find the root. Find out for this is the ratio.
Do you want me to see what they have in the back of the book for that one?
Well, let's use Pythagorean again, but proving it. So what they've done here, we're just going to find the ratio the same way they set it up. We know that 2 squared equals 1 squared plus b. And we're going to call this b. We're trying to find root 3. Okay? So in other words, what we've done, if we find the square root of this number, oh, that's how I got to set this up. Okay. So before I find anything, I'm just going to move 1 squared to the other side. So I'm set with, b squared. Okay? So this ends up being 2 squared plus 1 squared. And I'm going to isolate it to b. So I'm just going to say b is equal to the root of 2 squared plus 1 squared. Okay? Yeah. So this is going to be 4. Oh, it should be minus. That's what I'm like. Why is that plus? When I bring the 1 over, yeah, it should have been subtracted by. Does that make sense?
Yep.
See the mistake? Okay. So we have 4. Subtract 1 is, we know it's root 3, which is exactly what that is, right? That makes perfect sense. In our ratio, what this essentially says is, let's try to tie it to letters. 2 is our hypotenuse. So what this is really saying is our hypotenuse squared subtracted by the opposite side squared is going to be our root. So if I square 28 and subtract the square root of 14, I'm going to find out whatever this side is. That's what will be the root. So in other words, if we go to put this down, I know that that side b is going to be the root of hypotenuse squared is 28 squared subtracted by 14 squared. And we discovered what that was actually in the other one. It was like 500 and something. 588. So I don't know if they want us to keep us in radicals. They might want all answers in radical form, like not point by point. So this is technically the root of 588. Now, I know that's 24 point something from before, and we know this is going to be 5 point something from before. See what they want in the back of the book in terms of the whole idea here is just trying to recognize which of the special triangles you have, and specifically with this triangle here, this one here, you have to figure out whether angle is 30 or 60. The first one's pretty easy because one's 45, the other's 45, so they're identical.
Yeah,
This one's a little more difficult because between 90 and 60 is the distance of 1. 90 and 30 is root 3. It changes a bit. So that's the tougher of the two triangles. You have to have both of these memorized. Those are special triangles. You have to have them memorized in order to solve these things. These are the inverse functions. So all they're saying is cosecant sine is 1 divided by sine theta. So what they've done here is they've given us cosecant 30, secant 30. The reason they've given us those is so that you can apply the special triangles, but know that they're the inverse of it. So if they tell you that something like cosecant 30, okay, I don't know how to set up a special triangle with cosecant. We haven't learned that yet, but we know how to do it with sine, right? And we know cosecant deals with sine. So all they're telling us is that is actually equal to 1 over sine 30. Yeah, we can replace the thetas. We know the theta is going to be the same, so it's 1 over sine 30. So in other words, I can deal with a special triangle, and whatever my answer ends up being, I just 1 over that answer. So we know if they've given us to us as numbers, as a special triangle. I'm not sure how your teacher wants you to set these up. If she wants answers written as radical, or she wants it written as other things. Sine 30, I think it's like half.
Yeah, 0.5.
Yeah, so it's 0.5. So in other words, cosecant 30 is also equal to 1 divided by 0.5, and 1 divided by 0.5 is 2. So cosecant 30 is equal to 2.
Okay.
Okay? The other way you could have, yeah, that makes perfect sense. Same idea with secant. If they've given us, what do they have they given us? They've given us secant 45. So secant 45, we know, is equal to 1 over cosine 45. What's cos 45?
0.7.
0.7. So we know it's actually 1 over 0.7. And then if you were to divide that, whatever that's going to equal, 1.4. So let's check the back of the book, see if they want it written that way. We got 2 easily by plugging the numbers in. Technically what they wanted us to do, again, is they wanted us to set up a special triangle. Yeah. They wanted us to set this up. And we knew sine 30. So this is 30. No, sorry. I'm used to this being 30. Always draw the triangle the same and then just flip it for yourself. That way it's easy to memorize. We know that this is 1, root 2, and 2. Well, I know that sine 30, that's this here, is opposite over hypotenuse. So that's 1 over 2, right? 1 over 2 is equal to sine 30. And I know cosecant is the inverse of that. So inverse of that means we just flip these two. So it's 2 over 1, or in other words, 2. Okay. The other triangle was dealing with cos. Sorry, no. What did they give us? Secant 45, right?
Mm-hmm.
Secant is also the inverse of cos. So really this is equal to cos 45, okay? So let's just talk about cos 45 alone, okay? So let's pretend we're dealing with a question that only says cos 45. We'll do the inverse stuff after. Well, cos 45, I know I have my special triangle. This is 45, which then means this is going to be 45, right?
Mm-hmm.
When those are the cases, I know it's not drawn the scale. This side and this side are both 1, and we know that the square root, right? The rule for cos is, do you know what cos is? Cos theta is, do you know what it is?
Opposite over.
What?
No.
No. So ka, C-A-H.
Oh, A over.
Yeah. So adjacent over hypotenuse. What works out great here is both of these angles are 45, so I can just choose one. I'm still going to get the exact same answer. So let's say we choose the top one, right? Adjacent is the side touching that's not the hypotenuse, and the hypotenuse is root 2. So what this says is cos 45 is equal to 1 over root 2, but we're looking for secant. So in other words, they want us to invert this answer. So if I invert that answer, I put root 2 on top and the 1 on bottom, which means it's equal to root 2. So that's if they want things written as radicals, as a square root. You could find what our answer would have been. Where's the square root? Second function root.
Oh, 100.
Second function root 2 is equal to 1.41. This was exactly what we found before. Okay.
How
this
did
is
you
how
know
do
to use that 45 and not that one?
Let's use that one. Doesn't really matter. Am I still recording? Do I have time? Give it 1 minute. Ready? Let's say we use that one, okay?
Yep.
Cosine of this, adjacent, hypotenuse. Adjacent is 1,
Okay.
hypotenuse is root 2. Didn't really matter which one I used. I still got the exact same answer.
Okay.
Does that make sense?
Yep.